Very pleased that we have Dave Siegel today, who's going to be telling us about the recent fieldwork in the North Atlantic. And then after that, I'm just going to be giving an update in terms of the ocean decade. So without further ado, over to you, Dave. Thank you very much.
Okay, well, thank you. I'm very overwhelmed, actually, to talk about this. It's been a long time coming. So let me figure out how to do all this. Get back to the beginning. That's the end. Okay. Does this work? You see slides?
Yeah, that works fine, Dave.
Okay, perfect. So this is the first look at exports. The Exports North Atlantic Field Campaign. We came back not even a month ago, so we're still samples are back where they're supposed to be. We're still waiting for things to be shipped home. So that's where we're standing right now. So just real briefly, this is, oh please, okay, here we go. Just a reminder about what exports is about.
Can I just ask people to put their microphones on mute, please?
So the goal of export is to predict the export fate and carbon cycle impacts of ocean net primary production from satellite observations. Our focus has been on the quantification of export pathways and NPP fates over a range of ecosystem states. Our first cruise was in the summer-fall of 2018 in the Northeast Pacific at Station P in the Pacific. And we're trying to get at that contrasting state now by looking at the North Atlantic, or we did. The emphasis is on a predictive understanding by measuring process and using that to understand what the regulated process is. It leverages lots of advances in remote sensing, imaging, in situ imaging, genomics, autonomous tools, etc. One of these buttons going to make this go. There we go. So the goals of the North Atlantic cruise was to find that contrasting end member. We wanted big signals in biomass and exports with low flux attenuations and larger phytoplankton. We wanted to see post-bloom conditions with active zooplankton and large DOM signals. And we wanted to work in an environment that had high mesoscale and submesoscale energy that would drive patchiness in biomass and net prime production, but also lead to vertical advective fluxes. Our goals are to assess all three export pathways, that is sinking particles, that is the advective or mixing pump, and then the animal mediated ones due to migration, while still enabling a Lagrangian frame so we can interpret the process measurements. And we had to meet all these science goals successfully during a global pandemic, and I think that's all I'm going to say about the global pandemic. I'm having problems advancing. There we go. So this is the view of what the array looked like, modified from our Pacific one. We had 3 ships. The NASA supported the James Cook to operate as a process ship measuring rates. We had the Discovery that was doing spatial surveying and other operations, and then the Woods Hole Oceanographic Institution's Ocean Twilight Zone chartered the Sarmiento de Gamboa to look at other things and to look at higher trophic levels and to test a bunch of equipment. We had a bunch of autonomous vehicles out, both gliders of various kinds. We had bioargo arrays. There was surface tethered, neutrally sediment traps, and then neutrally buoyant sediment traps. The experimental center was this Lagrangian float, and I'll talk a little bit more about that in a bit. And we wanted to site it at PAP because that's a place where we know a lot of stuff about the ocean, and there is a mooring there. So the plan was to do this for 28 days on site. So this is what the ships look like. There are in the middle is the Discovery. The one further away is the Cook. And then here's the Sarmiento de Gamboa. That's just the money shot from that Ken and his crew collected. One more. Come on, you can go. No? Fine. Okay, so real briefly, each of those components had a mission and a set of operations it did. The process ships were there to look at export pathways and the approximate causes following a Lagrangian frame that using that float as the center of every of the experiment. It's integrated other components to provide an end-to-end assessment of the carbon cycle impacts of food web processes, and it's to link these pathways to remotely sensible variables. So the focus was on sinking in the active migrant carbon fluxes, measuring characterizing the planktonic and microbial communities, and making a series of rate measurements. The survey ship had a bunch of missions. It was to provide sort of spatial, temporal, physical, biogeochemical context. It completed a lot of the process ships measurements and collected optical and other data to ground truth satellite algorithms, and contributed to the assessment of effective fluxes in this. And it was kind of the electronic sensor intercalibration exercises was done using the survey ship as the transfer standards, so to speak. We conducted spatial surveys and noontime optical casts with a bunch of instrumentation. We measured the Cafe Thorium group was out measuring thorium-234 fluxes. We had a group doing particle size spectrums. There was trace metal clean sampling and incubations were done, and high volume pumps. We worked with we looked at funnel features with a underway CCTD and conducted a 2-day edge experiment with the Sarmiento. The AUV group was to provide longer term context for this on scales missing from the ship, so it's longer time and smaller space. The Lagrangian float was used as the geographic center, and they contributed to the they'll contribute to the assessment of the effective export fluxes and helped and we use this to help assess the eddy features before the ships arrived. We deployed 3 of the gliders from the Discovery cruise right before ours, and sent them out to 3 target sites, and we deployed also a bunch of other vehicles. We had a bunch of partnerships which were super important. They extended the space and space-time sampling of the experiment, as well as the trophic extent of the experiment. The Ocean Twilight Zone group had a bunch of novel instrumentation out to do things, including this towed sled that was used during the Edge experiment. There is data from the PAP mooring and NOC and Stephanie Felipe's group operated a Slocum glider during all this. And so these partnerships were very important for us going forward, and really made this all work. So operating in the Pacific was pretty easy. We had what's shown here is just a operational model output of what the currents are here, and you can see that the currents are quite small. These are kind of like 3 or so kilometers per day, whereas in the Atlantic they're much larger. And so these huge differences makes it difficult to assess rates, run a Lagrangian experiment, concerns about just the logistics of chasing assets, and it creates patchiness and all sorts of things. So we needed to find a retentive feature somewhere near the PAP site for logistic reasons that is undergoing a decaying bloom. So we spent a good amount of time doing this, and so there was a kind of a whole working group of people who've been working together for a couple of years now, working on how to find that retentive blooming feature somehow near PAP. And we characterize this using remote sensing. And as we were preparing for the cruise, there were about 15 features we were following in time, and we did this for many years. And we conducted a bunch of dry labs so we could get this process right. So as the cruise was just about to sail, there were 2 features we were following, the two of these anticyclones that are identified here. We measured, we sent out gliders to both of them, which are shown here, and we chose A2 because it was near PAP, which is somehow this pink little star right there, and it had this very strong core where the of mode water. So we knew we thought it would be a very stable place to work. So here's the evolution of the experiment as things went forward. On the top plot is showing wind speed and significant wave height, and the significant wave heights are in meters. And you can sort of see the evolution, and what's shown in the bottom panel here are aviso geostrophic currents and sea level with the globe color chlorophyll A product, the kind of cloud-free product that they've been working on. And you can see that we had large changes that followed in time. The other thing to notice is that we had some good-sized storms. We were inoperable for about 7 days during the cruise, and these were some of the largest ships in the fleet. So here's some results from very preliminary results from the Lagrangian float that was made as the experimental center in this. And what's shown here is these are density, salinity, and oxygen saturation in the top row with density overlaid, and then contours of backscatter, chlorophyll, and nitrate on the bottom. And the thing to notice is the mixed layer depth is deepening as we're going forward, but there are events that are punctuated by both of these large storm events that bring denser water to the surface, and with that at times higher nitrate concentrations. We also see here that the chlorophyll that the backscatter chlorophyll fluorescence are both higher initially, and that seems to decay, which is what we're hoping to get at. And these and so overall we have a pretty good sense of is that the nutrients are mixed upwards in particle and particulate carbon is mixed downwards. The Lagrangian float stayed in the center of the eddy throughout the entire experiment, and we think that we have a very good chance of looking at budgets because of all of this. We know that the that the food web changed, and these are a series of the front pages of the dashboard that comes out of the IFCCB, and what we're showing here is just sort of samples taken every day during the cruise, and you can see that we've gone from a case where we have lots of big diatoms that are spread out to all of a sudden now shorts where there's still big things and lots of pennates, and then all of a sudden some smaller things. A lot of the variations from day to day are when we had to move out of the eddy because of avoiding weather. Those days we saw significant changes in community structure. So there's a bunch of stories here that'll be very exciting to unravel. How do I go forward, please? There we go. So just by the numbers, this is what the different components did. The discovery of the survey ship had 19 days of science. We had 7 weather days. We did a series of what we call spoke surveys, where we would go from the center and work our way outward from this. We did the edge experiment with the Sarmiento. There was lots of thorium. There was lots of pumps done for high volume pumps, McLean pumps. We had a series of trace metal clean samplings for that. Lots of CTDs. And what's shown down here is a schedule of what we did. The dark green are the optics casts that we did every day around noontime. But you can see that there's a series of pumps. There's a series, and this red stuff is when we were inoperable due to weather. Okay, the process ship had much of the same things. These are just sort of the range of operations that were going on. CTDs, nutrient buoyant sediment traps. There were 3 surface tethered trap arrays. The wire walker was put out. There were 10 Mach nest tows, both paired day and night, set up as day and night tows. Lots of zooplankton tows for collecting samples for experiments. We had 62 marine snow catcher deployments, which I think is a record. Lots of optic stuff, both scattering and hyperspectral irradiance, UVPs, a variety of you get a sense of the scale of the things that we're doing. The Sarmiento de Gamboa was out for what's the dates it was out? It was out for 24 days in total. They were focusing on deploying a set of new instrumentation, these minions, which are small imaging cameras to look at sinking materials. They deployed this experimental Twilight Zone Explorer, which is a time series sediment neutrally buoyant sediment trap array, neutrally buoyant sediment trap. It's not an array, and they had a series of Mach 10, which are 10 meters squared Mach nest tows that they did several done simultaneously with the Mach nest on the Cook, and then lots of tows with this Stingray device. So the AUV program had a series of AUVs. There were six here, both gliders. There were 3 gliders, 2 Bio-Argo floats, and 1 Lagrangian float. Here's an example of where they are. Where they were during the cruise. This showing both the gliders, and what's shown here is what the gliders were doing. Some were there to assess the properties of the core and support the Lagrangian float, and our assessments of what's going on within the feature and the small scale things around it. Some were sent out like the green, like the blue, and were sent out to would look at features quite distant. So just some final thoughts. I can't believe I'm saying this, but we accomplished what we set out to do. It's almost ridiculous to say that, but it's true. So and it's been a true team effort. I'm a pretty small part in all this. We've had lots and lots of challenges, but the bottom line is the ocean cooperated. We saw the North Atlantic spring bloom transition to export, and we can see that in the thorium data that we've gotten back so far. And all the while, the eddy remained retentive in that feature. So the feature that we chose was retentive. It kept the Lagrangian float inside it the entire time. We think we've done as good of a job as doing a quasi-Lagrangian experiment as one can do in a highly effective area, and and we have the data to assess the material budgets to prove that that's true. The ships were awesome. We had a great partnership with the Hui OTC people and the people at NOC. Again, it was a for many of us, it is as good of an at-sea experience as I think we have ever had. And I used to joke that exports is the most overplanned project in the history of science, or at least ocean science. But the planning worked. We had a lot of logistics to work out, working on ships we had never seen, working out of a foreign port, dealing with lots of ship and AUV operations and coordination between all this, working through a situational awareness so that we are in the right place at the right time, so we can do all those intercalibrations. It took a lot of ship to shore coordination, and there was a very active shore team that was doing a lot of the operations, telling us where features, where assets were, where were the AUVs, where were the drifters, all that sort of stuff in real time, getting that information up to the bridge so that the 3 captains can figure out where to go and what to avoid. And we had to deal with COVID, and that is a story in itself, but I don't want to go there. So, and each time, I just want to say that each time we would get an issue and somehow they all got swatted back down, you name it, it happened, and somehow we got past all this. Lots of help and lots of thanks to be given to the team. And so going forward, we have a lot of work to do. We need to make this data we need to clean up all of this data. We perform analyses on the samples that are returned. We have to make that data public. Everything on the everything that was collected in exports will be public within a year through the NASA CBAS data system. We need to synthesize our results and publish the papers that will come out of this phase 1 of exports. The plan, NASA's plan, is to, once that data is public, is to start to move on to a phase 2 program, which would focus on synthesis and modeling, combining the North Pacific and North Atlantic work that we have done with data from around the world that have already been published from other people. So with that, I'd like to say thank you. Is this going to work? I can't move the cursor today. There we go. So thank you very much. This is just some views at sea. I think there were as well as having an inordinate amount of weather. And I just have to say that we saw an article that the month of May, the United Kingdom had a record amount of wind power generated by the wind energy folks on the UK, and we know why. But besides that, there was an inordinate number of birthdays here, and the bakers on both the ships did a great job making birthday cakes, including poopy ones and ones that are shaped like gliders. And then there was battling. We spent a lot of time battling COVID, and there were ducks. So with that, I'll say thank you very much.
Excellent. Thank you very much, David. I mean, that really does look like a spectacular bit of fieldwork. Questions. I'm sure people must have some, so turn it over to anybody who's got a question. Either raise your hand or just please ask a question. We should check whether we got anything in the chat.
Yeah, and I will make the slides will be public. We will make them available. So if you want to know the details that are there, we've got them. Yeah,
Marty, you got a question?
Yes, I have a question. Can you listen? Can you hear me?
Yep.
Yes.
Great. Well, thanks, Dave, for this great talk, and well, it was impressive. And my question is, as the project moves into this synthesis and modeling phase, is there going to be an open call, for example, for modelers interested in using the data sets and collaborating with experts?
Well, the call will be my understanding. I'm not a program manager. I'm just a professor, and so I don't. The plan, as I understand it, is to have a NASA ROSES solicitation that would let American-led programs to do synthesis and modeling of the data. So synthesis of the data sets that were collected and modeling of them, of how that works towards understanding what are the carbon cycle impacts of these processes. So, but the data will all be public. So, it's, that's the, so it can be used by anyone through but the solicitation will be through the standard NASA channels.
Right. No, I think it's really very nice that the data will be all public and published on the CBAS database, but it would be nice if there was a coordinated effort to do some modeling activities with different models and different setups. But well, that was just something that came to my mind, so thanks.
Yeah, no. I think you're, the goal, the goal of how NASA would probably want to do this is to have an open solicitation and see which projects answer things. There are 3 science questions that exports was designed around, And the phase one is dealing with the first two. What is the role of the upper ocean ecosystem in the export of material from the surface? The second question is what happens to that once it goes into the interior? How does that inform what the remineralization length scales are and that sort of stuff? And the third question is how do we use all of this to understand the present state of the ocean carbon cycle and its future states? So there's obviously modeling is a huge part of that. So how that gets done, I don't know. It's an opportunity, hopefully. And I'm not in charge, so we will see how this goes.
Excellent, thank you. Morten, did you turn on your camera because you have a question?
Yeah, well, I actually have a compliment, a question, and a peeing contest to settle.
Go for it.
So first,
okay.
So the first, I'm really impressed that you managed to pull this together with 3 ships and all this work during the COVID and all the other things that went on. I mean, it's really, really impressive work. And then the question is, how was the weather? I know you had some bad weather, but was it at least cloud-free so you can use the satellites? And then the peeing competition, which other people might call a pissing competition. I was just checking.
Something stupid. I'm sorry. I know what I said.
No.
I
I was just checking because I thought, actually, I don't know how many snow catchers we did during summers. So I went to the cruise report and we did 128 snow catchers.
Okay, I made that up, Morten.
That's fine.
I apologize.
No. It was just fun. Sorry.
Yeah. So we had an inordinate amount of weather. There's no way to say that the crew was surprised that was May. And there were several events where we had that we had 7 meter seas, but they were the weirdest storms I've ever seen because it was clear. And considering and so we got several large scale images, ocean color images of the entire sort of 10-degree box that we were doing our planning within, which was phenomenal. And I had been gone back the last, from the beginning of time and stepped through all these looking for what do April, May, and June's look like. And I couldn't find hardly any. We got 2 very excellent ones and probably a couple more. So that part of the game worked out very well. Whereas when we worked in the North Pacific, we never got an ocean color image of the entire domain in the 28 days we were there. So anyways, so that part of it was super exciting. And sorry, I made up a number. You caught me.
Don't worry. It's really great to hear that you at least got cloud-free conditions, but also this whole time series at the pub, right? That you actually could follow from the bloom start to the demise of the bloom and the export. I mean, that's normally, Adrian, when you are going and the times I have joined, it's just for the service, which is somewhere randomly in the scheme sometimes, depending when the ship is available, right? And then we've been lucky and not so lucky, so good.
I do think that one of the other major things that will come of this is that by working in this eddy frame, that we were kind of as Lagrangian as one can be in this world, and so we could see changes. There's obviously spatial changes in those images I showed from globe color. You can see it's swirling around chlorophyll from the south up north around the feature, but within the feature it was pretty coherent, and it might be, yeah. And I think that's going to be a big part of our, once we finally look at the data in sort of great detail. I mean, it was, we spent a lot of effort moving data from the ships to land and from the land to sea. So we kind of knew what was going, and from the gliders to the ships. So we kind of knew what was going on as we were doing this. And, there was a couple of us who were just analyzing data in real time. So it was kind of, so we have a pretty good sense of at least the physical large scale coupling to the biological data sets already. Many of the other stuff is sitting in liquid nitrogen, and it's going to take us a long time to get that all through, like the genomics and stuff like that.
Thank you. A quick question. So in terms of the eddy, did you see any dynamics sort of that you would regard as being specific to the eddy, in terms of maybe some mesoscale events?
We did spend some effort doing an edge experiment. So we spent 2 days of time with the Sarmiento and the Discovery together, finding features on the edges that we identified using finite time Lyapunov exponent things from the altimetry, and then cross those fronts to what to look at the subduction of biomass and that sort of things. We operated it where the Stingray, which is a towfish platform that was on the Sarmiento, it also had a bunch of imaging capability, was making its towfish data, and Heidi Sosik would send us mat files, and we would plot them up in real time and be able to then go, let's sample here, here, and here. We trip bottles in those locations, try to look at that. So we'll see how that comes out. It's very exciting. The other thing is that it was very clear we had a bunch of drifters that we put out, and they kind of went around and did their little conga line thing. But you can follow very nicely what the role of inertial waves were in that, and the inertial forcings, and you can see how the eddy had modified a lot of that. Did I answer your question?
Yeah, very interesting. I look forward to seeing that. Actually, it sounds like you've got a fantastic data set there.
Yeah, except that we need to do 105 more snowcatcher deployments. I understand.
I mean, I can really go in numbers and destroy you guys. I'm just going to use this opportunity. Maybe not in snowcatchers, but in everything else. So, how many days of quarantine? 1,040.
Yeah.
Get that.
Okay. So, I think we draw a line under these competitive numbers.
And I will say, I mean, do understand, for us to get this done, we had to make all of our planning pre-vaccines, pre-everything, and getting the COVID stuff done. The Room 2 hotel in Southampton was great. Just a quick shout out. The entire team spent 2 weeks there ahead of time in quarantine. Somehow NASA figured out how to fund all that somehow. It's kind of a bunch of miracles here. So,
well, I'm delighted that it came off after the time that's gone into it. So thank you for talking to us about it. And as Dave said, we'll put the slides up. I'm sure we'd be happy to take any questions in the chat, or just sort of email him or the team afterwards. But thank you.